Hello, everyone. Mr. Sutherland here with the last section that we're going to cover this year in advanced pre-calc. And this is going to cover the first major idea of calculus, the derivative. And so when you guys take Calc 1 next year, about 2/3 of the course is dedicated to this one topic that we're going to introduce today. Now, for the notes this time, I'm going to do it a little differently. I'm going to go through this first page of the notes, and I'm going to go through example problem number 1 with you. Then what I'm going to end the video there, because I don't want this to be a video that lasts 25 to 30 minutes. Then what I would like you to do is you're going to do problems 2, 3, and 4 and submit your answers on Google Classroom. Once you submit, you'll be able to look at a completed solution to this notes, and you kind of see what you're doing and where you made mistakes if you made them. So what is the derivative? What does it represent? Well, we're going to start with what we ended last class with, talking about average rate of change. So here we're given a function, and we're asked to find what is the average rate of change for that function from 0, or excuse me, x equals 1 to x equals 1 plus h. And remember what h is. H is the distance from 1 to the next point that you're going to check from. So when we do this, the average rate of change, remember, is f of b. So I'm going to go average rate of change. And sometimes the triangle for the Greek symbol delta is used to represent the word change. The average rate of change is f of b, which in this case is 1 plus h minus f of 1 all over h. Now remember, this thing on the left, this is called the difference quotient. And we worked with simplifying those last time. So now let's do the math behind this. So f of 1 plus h means I'm going to take 1 plus h and plug it everywhere I see an x into f of x. So I have 1 plus h quantity squared plus 1 plus h minus 5, then minus f of 1. So f of 1 would be 1 plus 1 minus 5, so minus negative 3 over h. And the reason that this is h is really, what am I doing? I'm doing 1 plus h minus 1, right? I'm subtracting the inputs. So now, what does this simplify to? Well, here 1 plus h quantity squared is h squared plus 2h plus 1 plus 1 plus h minus 5 plus 3 all over h. Well, in the numerator, I have h squared. 2h and h is 3h. 1 plus 1 minus 5 plus 3, all of that goes away. And I still have this all over h. And now, since everything has an h, we can simplify to this. So this is a representation for the average rate of change between any 2 points of this function, as long as my first point is 1. The average rate of change is going to be whatever that difference is between the 2 points plus 3. So let's look at what happens here. So if I wanted to know the average rate of change from 1 to 3, instead of doing the slope formula from 1 to 3, 1 to 2, 1 to 1.1, we can now use this difference, this simplified difference quotient. We got to be h plus 3. So if I want to know the average rate of change from 1 to 3, that means the h value is 2. And so the average rate of change would be 2 plus 3, which is 5. And so what that means is the average rate of change between 1 and 3 is 5. So remember, we call this line a secant line, and the slope of that secant line is 5. Well, now, what's the average rate of change between 1 and 2? Well, now, the h value is just 1, so the average rate of change would be 1 plus 3 is 4. So now we're looking at 1 to 2. The slope of that secant line is 4. Now, what about 1 to 1.1? Well, now the average rate of change of the h value is just 0.1. So the average rate of change would be 3.1. That's kind of hard to show here, but we can start to see what's going on here. And then we have here, we would have 0.01, So 3.01, and then we'd have 0.001, and so 3.001. And so if we look at these numbers, what's happening to the h value? The h value is getting closer and closer to 0. And as that's happening, the average rate of change is getting, looks like, closer and closer to 3. And so what we're really finding here is when that average rate of change, when that h value is 0, it can't be 0 exactly because here I would be dividing by 0. I'd have something that's undefined. When that's getting closer and closer to 0, instead of finding the average rate of change, we're actually finding the instantaneous rate of change. And if I look here, here the average rate of the h value is 2, and as I make that h value closer and closer to 0, it's no longer a secant line. When h is 0, it's a tangent line. That line, though, it goes away because it can't divide by 0. So how do we identify something? How do we approach something where we're getting closer and closer to 0, but we can't actually reach there? That's when we use the limit. So if I want to know the instantaneous rate of change of f of x at x equals 1, then what I'm going to do is to find the instantaneous rate of change. I am going to take the limit as h approaches 0 of that difference quotient. And we showed in part A that that difference quotient simplified to just be 3 plus h, so that when I make h 0 to apply my limit, I get that the instantaneous rate of change is 3. This rate of change, the idea of finding out what's happening at an exact moment in time, that's the whole idea behind the derivative. So the derivative of f of x at x equals a, denoted by this notation, which is read f prime of a, is the limit of the difference quotient. Now, what does it represent? A couple of things. In the rate of change, the derivative represents the instantaneous rate of change of f of x at x equals a. Geometrically, average rate of change represented the slope of the secant line. The derivative represents the slope of the tangent line of the graph at f of x at x equals a. So a tangent line just touches the graph at one point. So the whole idea is, if I ask you to do what is the instantaneous rate of change, what is the slope of the tangent line, what is the derivative of a, I'm asking the exact same question. So let's see how that works. So example 1, find f prime of 2 if f of x is this function. So f prime of 2 means I'm going to find the limit as h approaches 0 of. Now, since I'm asked for at 2, that is my a value. So I'm going to do the limit of f of 2 plus h minus f of 2 all over h. Now, the rest of this, I'm always going to keep this limit notation here until I use the actual limit. So now, what do I have to do next? Well, what did we do last time when we simplified a difference quotient? F of 2 plus h means I take the 2 plus h, and anywhere I see an x in my function here, I replace it with 2 plus h. So I have 3 times 2 plus h quantity squared plus 2 times 2 plus h. Then I have minus f of 2. F of 2 is 4 times 3 plus 4, so that is 16, and all of this is over h. Now it's just algebra and arithmetic the rest of the way. So I keep that limit notation out front. That's going to be there until I plug in 0, and I'll explain when that happens when we get there. But I always just write that notation out front. So now, first thing I'm going to do is 2 plus h quantity squared. And just, I want to make sure everybody understands what I'm doing with this. 2 plus h quantity squared means 2 plus h times 2 plus h. So 4 plus 2h plus 2h plus h squared. So this is 3 times h squared plus 4h plus 4. plus, I can distribute this to 4 plus 2h minus 16 all over h. So now, let's simplify a couple more steps. So I have the limit as h approaches 0 of 3h squared plus 12h plus 12 plus 4 plus 2h minus 16 all over h. I have the limit as h approaches 0. Now I have 3h squared. 12h plus 2h is 14h. 12 plus 4 minus 16, the constant goes away, so I just have h left in the denominator. And now everything has an h, so I can do limit as h approaches 0 of 3h plus 14. Now I can apply the limit. When h is 0, this goes away, and I'm left with 14. So what that means is f prime of 2 is 14. The slope of the tangent line to f of x at x equals 2 is 14. The instantaneous rate of change of the function f of x at x equals 2 is 14. Those statements are all synonymous. They mean the same thing. So what I would like you to do now is try problems 2, 3, and 4. You will put your answers into Google Classroom and upload your work so I can kind of see where you're at with this. And then you'll have some problems with Delta Math. But just to give you a preview here, number 2 says find the instantaneous rate of change of f of x at x equals 3. So instantaneous rate of change at x equals 3 is just telling you find the derivative at 3. So when you find the derivative, we always do the limit of the difference quotient. So I have the limit as h approaches 0. F of the a value is 3. So f of 3 plus h minus f of 3 all over h. And then you go through the same algebraic process that you see above. So try this for problems 2, 3, and 4 and see how you do with it. All right, guys, take care. Talk to you later. Bye.